Welcome back. Okay, now that you've had a chance to play with what goes into climate solutions in the En-ROAD simulator, in this tutorial you'll get your first look at the actual scenarios on which the IPCC bases its projections, the so-called Shared Socioeconomic Pathways framework. To motivate this framework, let's look at the causal chain that ends in climate damage. This starts with fossil fuel production that feeds energy consumption, producing greenhouse gas emissions that trap heat, that heats our environment, finally generating damages through effects like extreme weather events. Okay, so let's look at a hypothetical projection of future climate damages and how we can reduce them. The goal here is to stay out of the region of high climate impacts shown here by high intensity of red. That's where we're headed currently, because we're still emitting large amounts of greenhouse gases from burning fossil fuels every year. The first and most important thing we can do is to cut those emissions, to flatten the impact curve. This can be done through demand-side mitigation that reduces consumption and supply-side mitigation that lowers the emissions intensity of consumption. The reality, though, is that there's so much greenhouse gas in the atmosphere already that even with our best mitigation efforts, it'll level out too far in the red zone. This means we'll also need to remove large amounts of greenhouse gases to get back down to a level of damages that's manageable in the long run. Emissions removal or negative emissions technology might be able to eventually restore the balance, but these technologies are unlikely to ever scale up or soon enough to prioritize them right now. So the damaging effects will likely exceed what we can tolerate for some time to come. We then need stopgap measures that temporarily cool the planet to keep us out of the red zone in the meantime. This is solar radiation management, or SRM, that for instance would reflect the sun's radiation out into space before it converts to heat and has a chance to get trapped. And then finally, we will do what we can to limit the damaging effects of warming by adapting. This can be done in place, like with temperature-controlled environments and heat-tolerant crops, and by moving humans and food production, as well as natural and physical capital, to less affected regions. Stepping back, note that this picture of the physical goals in the problem is actually ambiguous about the socioeconomic path we take to realize it. That path is laden with choices about what we value and will be implemented with all the messiness characteristic of human society. The SSPs were developed as a way of filling in the socioeconomic content behind this success trajectory with different possible pathways that our society might take. To combine the best of expert opinion and modeling results, the SSP architects started with a narrative-based methodology. They first established a set of shared policy assumptions common to all pathways and narratives. The SPAs are things like barriers to how fast we can respond based on where we are now, and what kind of policies are implemented and how. They then generated a set of shared socioeconomic pathway narratives constrained by these assumptions, but with differences coming from different assumptions about things like global population growth, access to education, urbanization, economic growth, resource availability, technology developments, and drivers of demand, such as lifestyle changes. They tried to include assumptions about most of the topics relevant to the start of the causal chain of climate damage studied by researchers doing mitigation analysis, and also at the end of the chain studied by those doing impact, adaptation, and vulnerability analyses. They then selected integrated assessment models well suited to describe these narratives and implemented these models of different pathways with corresponding physical modeling efforts. A given pathway in the framework is then specified by both a SSP narrative and a level of climate forcing coming from the representative concentration pathway framework that preceded the SSPs, which lacked such socioeconomic variation. Finally, in a massive computational undertaking, they ran all the integrated assessment models in all narrative-derived pathways and analyzed the results. Okay, so what are the narratives used in the SP framework. Let's introduce them here for the first time using these one-sentence summaries. So in the first, sustainability narrative, this is the most optimistic projection in which we transition to a society of sustainability-focused growth and equality. The second SSP is middle of the road. This is more of the same with reduced country-level inequality. SSP 3 is regional rivalry. This is in many ways the worst scenario in which there's a fragmentation of the world and the world order and economic stagnation. In SSP 4, known as a road divided, this is a narrative where we make gains, but relative inequalities worsen. And finally, SSP 5 is a fossil fuel development narrative, one in which we rapidly continue to develop fossil fuels, which means more technology to adapt, but also lots more CO2 to deal with. So these only define the sort of socioeconomic pathway at a gross level. To combine them with the different possibilities of forcing and emissions, or emissions and then corresponding climate forcing set by the previous representative concentration pathway framework, then gives the specification of a given scenario. So in this grid, each box is a given scenario, and each scenario can be run by one of a handful of models that were chosen. So some of the gaps in this grid exist because the two axes actually constrain each other somewhat. So this gap here in the top left is there because sustainability pathways, which limit emissions, restrict how much forcing is possible. Likewise, the gap in the bottom right is explained because pathways with heavy resource use, such as SSP5, that include substantial emissions, don't allow for futures in which forcing is this low. It's just not possible given the assumptions. There's a baseline pathway for each narrative, here shown in blue, which assumes a minimal amount of mitigation. We'll cover how the research community came to define these 5 pathways, these 5 SSP narratives in the next tutorials. But first, in this tutorial, we're going to look at only a couple scenarios so you can get acquainted with them in more detail. We're going to look at the SSP1 2.6 as a sort of best case, and an SSP5 8.5 as in some cases the worst case. Okay, have fun.